Today we'll look at solving equations using indices. Now, usually when we solve an equation, the unknown is usually in the form of the base, okay? And if we have an equation where the unknown is the exponent or the index, right, we will call this an exponential equation. So exponential equations are basically where we are trying to solve for the unknown, where the unknown is the index, power, or whatever you want to call it. Okay? So just to recap and remind ourselves how we solve simple exponential equations. When we're solving these types of equations, we need to look at the bases that make up the two sides of the equal sign. Now, if we want to solve an exponential equation, we need to equate both sides with the same base, right? So we need to make the bases the same. So I already have this in its smallest base, 2 to the x, and I want to change 64 into base 2. So with some simple logic, we could quite easily work out that 2 to the power of 6 is the same as 64. Now that we have the bases the same, we can actually drop the bases and equate just the exponents, right? If 2 to the power of something is equal to 2 to the power of 6, that must mean that x must be equal to 6. So we can drop the bases out and solve just the exponents. Okay, so that's a nice simple example to get us started. Let's look at some more complicated examples. Here they ask us to solve the equation 2 to the power of 3x plus 1 equal to 8. So the first thing we notice is that the bases on both sides of the equation are not the same, so we need to change that. So on this side, nothing's going to change. We still have 2 to the power of 3x plus 1, and this is equal to, we can change 8 into base 2, we will get 2 to the power of 3. So now that we have 2 to the power of something equal to 2 to the power of 3, we can drop the bases out and just equate the exponents. So we can have 3x plus 1 equal to 3, and we can just solve normally. So we can move the 1 to the other side and divide by 3, and we'll get x equal to 2 over 3. So if x is equal to 2 over 3, that will satisfy the equation. Okay, let's take a look at another example. Here again, we have solved the following equation, and the first thing we once again notice is that all the bases are not the same, and not only that, we have this multiplied term in between. And so what we want to do first is simplify that into one base on one side equal to something with the same base on the other side. So we'll change all the bases first so that they're all the same. And usually the clue is going to be that it's the lowest prime factor. So 3 here is the lowest prime factor. So I'm going to have 3 to the power of 2x minus 1. Nothing's going to change there. Multiplied by. Let's change 9 into something that's base 3. That would be 3 squared. And this is all being raised to x minus 1. On the other side of the equation, we have 243, and we can quickly use some intuition. We know it needs to be base 3, so what 3 to the power of what gives you 243, and we can see that it will be 5. So one more step to go. We just need to simplify this over here so that we can add it to this over here, because they have the same base. So 3 to the 2x minus 1 stays the same. I'm raising a power to another power, and so I need to multiply the exponents. Okay, so it's 2 times x minus 1. So we would get 3 to the power of 2x minus 2 equal to 3 to the power of 5. Here I have the same base being multiplied, so I can add the exponents. So I'll get 3 to the power of 2x minus 1 plus 2x minus 2. And this is all equal to 3 to the power of 5. Right, I have the same base on both sides, and so I can just drop the bases and equate the exponents. So that's what you're doing when you're solving exponential equations. You're trying to get the same bases so that you can drop them and just equate exponents. So we have 2x minus 1 plus 2x minus 2 equal to 5, 4x equal to 8, and x equal to 2. And you can always double check by putting your answer into the original equation and checking if the solution if it works. Okay, let's look at the next example. So here we have to use just some ideas behind or some of the rules of exponents that we know to solve these. So we want to solve these two simultaneous equations together. Okay, so you can see we have x's and y's, and the same thing applies. What we want to do is we want to get the bases the same so that we can make some kind of equation from the exponents. So having a look at the first equation, we have 9x times 27 to the power of y. So we want to change all of this to the same base, and that base will be 3. So we'll have 3 squared to the power of x times by 3 cubed to the power of y equal to 1. Now we don't want 1, we want to try and write 1 in base 3. And if we remember our law of indices, anything to the power of 0 is 1, so that will be equal to 0. Now we can add these two exponents on the left-hand side together. So we'll have 3 to the power of 2x plus 3y equal to 3 to the power of 0. So I've multiplied my exponents here and just added them together because they are being multiplied. Now that the bases are the same, I can drop the exponents. And here I have my first equation. Now we're going to do the same thing on the other side. So we're going to have 4 to the power of x. 4 is not the lowest base, so we're going to change that to base 2. We're going to have 2 to the power of 2 raised to the power of x. And that's divided by, we have the square root of 2, which we want to write in an easier way, and that we can write as 2 to the power of a half. And this is being raised to the power of y. And this is all equal to 128. Now we don't like 128 because it's not base 2. So we need to think of a number on base 2. And if we remember from the previous example, 64, this will just be 2 to the power of 7. Now these two are being divided by each other. So we need to subtract the exponents. So in one step, I'm going to go 2 to the power of 2x. And I'm going to take away, or I'm going to multiply y by a half, because we're raising a power by a power here. And so I'm going to get y divided by 2, and all of this is equal to 2 to the power of 7. So once again, the bases are the same, so I can equate the exponents. So I'll get 2x minus y over 2 equal to 7. There's my second equation. Now, from here, these are just two simultaneous equations. They're two linear simultaneous equations, so we can solve them normally, either substitution or elimination. So what I'll do is I will change this into 2x is equal to 7 plus y over 2, right? That tells me that I have 2x equal to 7 plus 2y, so I can say 7 plus y over 2 plus 3y equals 0. I can multiply everything by 2 to make my life easier. 14 plus y plus 6y is equal to 0. And you can see that y will then be equal to negative 2. And we can just substitute negative 2 into either one of the two equations, and we can solve for x, and we'll get x equal to 3. So a great look at how we can solve simultaneous exponential equations by first looking at each equation separately, making the bases the same to then create an equation from the exponents. Okay, and one final example. So the first part of the question says, solve the following equation. Now this is just a normal quadratic equation, and so we're going to solve this by factorizing, because it'll be the easiest way. So we'll have 4y squared plus 3y minus 1 equal to 0. So I need to consider the factors of 4 and the factors of 1. Well, luckily the factors of 1 are only 1. And now we need factors of 4 that can make 3. And that will be 4 and 1. And I need positive 3, so I want plus 4 minus 1. Well, that'll give me solutions of y equal to 1/4 or y equal to minus 1. Right, now that we've solved part A, they say use your answer in part A to solve the following equation. Right? 4, 2x to the power 2 plus 3, 2 to the power of x minus 1 equal to 0. And if we have a look here, what we can do is this is a simple substitution. If you just substitute y in place of 2x, because that's all that's happened, we can very quickly, without worrying, solve this. So instead of y, I'm just going to write 2x must be equal to 1/4, or 2x must be equal to minus 1. So let's have a look at the first one. 2x equal to 1/4. I need to write this as the same base. So 2 to the power of x is the same as 1/4 can be written as 2 to the power of negative 2. And so x is equal to negative 2. Now on the other side, I have 2x equal to minus 1. Now this is an exponential function. This is a positive exponential function and a positive exponential function. If we remember what they look like, it starts on this side here and goes in this direction. It can never be negative, and so we have no solutions over here. Okay, this is undefined. We don't get negative solutions from this function. If there was a negative in front of the 2x, then we would have solutions, because then we would be considering this function here. That would be the reflection about the x-axis. So just a nice simple problem that we can sometimes solve quicker than we realize, just by remembering that when we substitute values for y, they can be substituted for more than just numbers. They can be substituted for other variables.